So this review is about session 1.9, divisibility. And I will emphasize on the basically the rules, that we are going to be using for this homework. Now, basically, all you gotta think about is this: we have a few key numbers that when you present me a big number, say 550, the question is, what factors can be divided into this number evenly? So factors just means divisor, just any number, right? That can go into 580. So here's what I usually do. Here's the rules I use. The rules. I will start with 2. So 2 is, of course, the smallest even numbers, right? So 2 can divide into any even numbers. So i.e., meaning specifically, means any numbers that ends with 2, 4, 6, 8, and 0. So that's of course 12, right? 24, 18, 30, right? So this was easy. 3. 3 can go into any number in the numbers who that all digits sum up to be a number divisible by 3. So what do I mean by that? So here's an example. Example. So let's just say 580, right? Let's just say. Now look at this. 5 plus 8 plus 0 equals 13. Can 3 divide into 13? No. So therefore, 3 cannot divide into 580. Let's try another number. Example. Let's say we have 690. Let's try 6. Right. Oh, you know what? Let's make one more number. Let's do like this. 27. Right. So 6,927. Let's try this. 6 plus 9 plus 2 plus 7. And that's equal to, let me say, that's 8. 6 plus 2 is 8. 8 plus 9 is 17. 17 plus 7 is 27, right? 24, right? Can 3 divide into 24? Yes. Therefore, 3 can also divide into 6,927. You can try using the calculator. Right? So basically, add up all the digits. If that number can be divided by 3, then you're good to go. So now let's try the next number. The next guy is 4. 4 is a number that can divide into any numbers that ends with that last 2 digits can be divided by 4. So what do I mean by that? Example. Say we have something ridiculous like 28, 24. Now, 4 can divide into 24, right? That is the last 2 digits. Therefore, 4 can also divide into 28, 24. Again, you can try that using a calculator, and it will always work. It's always the last two digits. 5. Now 5 is the easy one. 5 is can divide into any numbers that ends with either 0 or 5. Right? So like 5, 10, 15, 20, 25, 30, that sort of thing. So not too bad. 6. Now 6 is a bit tricky. 6 is 2 times 3, right? So since 6 equals 2 times 3. So I'm going to use this. Actually, I'm going to use it down right there, just to make it a little bit easier. Insert dot 3. Since 6 equals 2 times 3, so 6 can divide into any numbers that are divisible by both 2 and 3. So the meaning it has to be an even number, and when you add up all the digits, they have to be divided by 3, divisible by 3. So basically the first two rules put together. Now 7, we don't really have any rule for that. So let's just do 8, not really any rule. 9. 9 can divide into any numbers that that all digits sum up to be a number divisible by, this time is by 9. So it's almost like 3, but this time it's divided by 9. 10. And this one is divided into any numbers that ends with 0, of course. Right? That one's easy. So basically that sums up all the rules. Let me I can just kind of copy that into, let me copy that to the bottom. So rules of divisibilities. These two, and then the 4, and then these guys. So that basically tells us all the, that will help you with all the homework problems. And also later on, I know you guys are doing fractions right now. So these guys can help. You can basically look at number and immediately tell whether or not it can be divided by any one of those digits. Okay? And to be clear, these two and 5 and 10, these are the most important. As long as you know those 4, you're golden. Right? The other 3, you know it's there, you can use it. But later on when you do fractions, these 4 rules are going to be helping you. Because you want to start small. You don't want to be testing for the big numbers from the start. And just in case, if you ever seen 7 and 11, so if you ever want to try 7 or 11, right? My advice is, I recommend just do the long division. Or use calculator. It's a lot easier than using any rules that anybody provides. So that's all. So that's that. And I guess I'm gonna save this right here so you can use it later. And that concludes session 1.9.